Hello everyone, welcome back to this tutorial series. This is part 2. So in this part we will take a look at different built-in operators that are available in Blender, and also we will learn how to create custom operators. Okay, first question, what are operators? So let me go to Blender and demonstrate that. So I'm going to scripting tab and I'm going to just align this. Okay, so you can see BPY is the parent module, so we already know this, and you can see this, you can see OPS. Actually this is the operator module. Okay, so what is the use of this operator module? Actually every button clicks, mouse events, keystrokes in Blender is actually calling an operator. For example, adding a new cube, deleting a lamp, or creating a new scene, switching from one scene to another scene, everything is an operation. Anything that performs an operation can be qualified as an operator. So you can see here that we are having a lot of operators. Each performs some operation in a specific domain. For example, you can see here image and mesh, and also you can see screen, scene. So you can see there are a lot of domains here. So the operator is going to perform some operation over this domain. Okay, I will show you an example. I am here in this 3D viewport. Okay, so usually how we will select all the objects in a scene, we can click and drag to select the entire thing, or we can use the shortcut key A. Okay, so it is a toggle action, and while doing so you can notice one more thing here. Okay, actually this is the code that is getting executed when we press the A key. And one more thing you can notice here, it is from bpy.ops module. Okay, let's search for that. object. So object, why object? Because this is an object level operation, so everything here in the viewport is an object. Okay, let's search for select, and it is here, select underscore all. Okay, and action equal to toggle, and you can notice that everything is deselected. So if I run the script again, it is going to select everything. Okay, let me show you a different example. I'm going to delete everything that is here, and I'm going to create a monkey. Okay, and you can also notice that it is actually calling an operator, and it is a mesh level operation, bpy.ops.mesh, and it is a mesh level operation. So we can just look at the code that is here, and we can create our script set here, bpy.ops.mesh and press okay, and press right click autocomplete, and let's search for primitive, prami. Okay, primitive underscore. Okay, let's try a different one, cylinder. Fine. So you can also notice one more thing here. These are all the parameters that we can pass optionally to this function. Okay, I can specify vertices equal to 12. Okay, and radius equal to 4. Fine. And depth, actually this is the height, which is the z-axis. Okay, depth equal to 8. Okay, let's run the script, and you can see we are having a cylinder here. I'll show you a quick tip here. Go to edit and go to preferences, and under the interface tab you can make sure that you have enabled the Python tooltips. So what is the use of this one? So if I'm going to add a new object, or I'm going to perform any operation, you can just go and wait there in the menu. It is going to show you a pop-up. So from that you can get the code of that particular operation. This is not only for the viewport stuff, it is going to work for everything. So for example, if I'm going to this material section, and if I want to add a new material, you can see it is showing me the code. And if I want to add a material to this slot, so you can see I'm creating a new material slot here, and I will add a new material. So from here itself you can get the code, or you can take a look at this place. So it is your choice. Great. So now let's take a look at the context of operation. What does that really mean? Okay, I'll show you that. I'm going to delete everything that is here, and I'm going to just use this cube. Okay, the context of operation is really important while executing an operation. I'll show you why that is important. Okay, so let's take a simple example. What if I want to subdivide this cube? So we are in object mode, so what we will do, we'll go inside the edit mode, and we'll press W and click on subdivide. So we can subdivide this. We can't do this in the object mode. We need to go inside the edit mode, and then only we can get this menu. If you are going to try this in object mode, you won't get that option. That is great, but when it comes to script, everything is open. You can call any operation from any context, but while doing so we need to be very careful whether we are executing that operation in the correct context or not. Okay, let me show you this. I'm going to inside the edit mode and press W and click on the subdivide. Okay, and before doing so, I'm just going to note down this script bpy.ops.mesh.subdivide. Actually, that is the script which is getting called. Okay, so let me type it here. Okay, I'm inside the edit mode, bpy.ops. This is a mesh level operation, so mesh.subdivide. Yes, it is here. So I'm going to just call the function, and you can see it is getting executed here. So there is no issue. You can also see the result here, finished. Great. So if I'm not going to select this particular mesh inside of edit mode, okay, so I'm going to run the same script. So it is saying finished, but we don't see any result here because operators only work on a specific context. So most of the time, most of the operators going to perform action or its operation over a selected object. Okay, so now if I go to run the script, it is going to subdivide. So there is one more thing you need to keep in mind. Okay, let's go to object mode and let's try to run the same script again. And this time you can notice that it is throwing some error, and you can see context is incorrect. Yes, that is right. We cannot subdivide a mesh from object mode. We need to go inside edit mode and we need to run the script. Great. So this is what you need to know about context of operation. Okay, so now it's time for us to see what is the difference between selected and active operands. So operand is any value or any object, any data over which the operation is performed. So we need operands to perform an operation. Okay, for example, if we are going to add a plus b, here the operation is addition, and we are performing the addition using the operands a and b. Okay, and also you can notice this here. We are performing an operation called subdivision. So here the operand is this cube and this is the operation. Great. So let me show you an example of this. I'm having two cubes here. Okay, so I have already told you that operators work on the selected object. Okay, I'm going to perform an object level operation. Okay, so what operation is that? I'm going to duplicate this object. Okay, duplicate. Great, it is here. So I'm going to just call, and you can see a new object is getting created in the outline in the viewport, and I'm going to grab this. Okay, so you can notice that the operator, we have never mentioned anything about the source, that which object we want to duplicate. Actually, the OPS works on the context, the one that is selected. Okay, let's go deeper into this. So I have these two objects. Now I'm going to select both the object. Okay, now I'm going to run the same code again. Great. So it is working. So we are getting the duplicates of these two cubes. That is great. So this operator is working on all the selected objects. Okay, there are some operators that behave little bit different. I'll show you an example. Okay, let's dive deep into this. I'm going to create a cube. Okay, and also let me create a torus. Fine. So okay, we have two objects in the scene. So what I'm going to do is I'm going to select this one, and I'm going to apply subdivision surface modifier. Okay, subdivision surface. So you can see the subdivision surface is successfully applied to this object. Okay, now I'm going to just remove this, and I'm going to perform the action through script. So bpy.ops. This is an object level operation. So object dot modifiers underscore add. So the type of operator is, the type of modifier is subserve. Right. So great. So it is added to the modifier list, and also it is applied here. So now what I'm going to do is I'm going to remove this and select this also. So let me run the same script again, and you can notice that the operator added the subdivision surface modifier only to this object, not to this one. Why is that? But in case of the duplication, actually it worked on both the operand, right? Yes, it worked on both, but for this particular operator, it is going to work only on the active object. Okay, there's a difference between selected and active object. How you can differentiate between that? So let me select this one and select this one. The one that you select as a last is going to be the active object. You can notice the color difference. Both are selected, but this one is the active. Okay, let me create a duplication of this. Okay, so I'm going to select this, and this. You can notice that this is bright, and the color difference you can notice here. This is the active object, and all of these are just selected object. Okay, the one that is selected and active is going to be the one that the operator is going to consider for operation. Okay, there are few operators that is going to work on all the objects that we have selected. Okay, in case of this duplicate operator, you can see, okay, bpy.ops.object.duplicate. If I enter, it is going to perform the operation all of the object that we have. But in case of the one that we tried earlier, okay, I'm just going to select this and this, and I'm going to make this as the active one. Let's try this observe. You can see it is getting applied only to this particular object. So this is what you need to know about the selected and active object. This is very important. Okay, now we know what are operators, and we also know the importance of context while executing an operation. And just now we saw what are selected and active operands. Okay, now let's go and create our own operator. So let's see how to create custom operators. Blender allows us to write custom operators. This will help us to automate the task and solve some complex problems. The process is very simple. We first need to define the operation that we expect to be executed whenever the operator is called. So the first one is define the task. Then we need to qualify these set of tasks, these set of actions as an operator. And we need to register under the Blender's bpy.ops module. Okay, if you don't remember that, I will show you. bpy.ops. Okay, we can already see that there are a lot of operators here, so to register it here, then only we can call the operator from Blender. Okay, great. So I'm not going to use this Python interactive console. I'm going to create a new script here in the scripting window. So let me rename the script as my operator. This is just the name of the file. Great. Okay, now what we need to do is we need to import bpy. This is very important. Okay, you may ask me, you may have one question now, why we didn't do that here? Because it is already imported. Okay, so for example, if I'm going to say bpy dot, it's going to return everything. Okay, but if I'm not going to use this, and if I'm going to say print bpy, okay, if I'm going to run the script, it's going to throw me an error. But in case of here, if I'm going to say print of bpy, it is going to throw some output. So don't worry about this output. Actually, there is no error. Okay, so that is what you want to note here. So if I'm going to import bpy, and if I run the script, you can see it is successful. So this confirms that we have successfully imported the bpy module. That is the Blender module, Blender's Python module. Great. Okay, in the bottom right, you can see my console window. Actually, it's from window and toggle system console. We need this to see the output, so we can just enable that and have it somewhere. Okay, I'm having this thing here. Fine. So first, before creating an operator, we need to define the task we need to perform. Okay, so let me just jot down the task. Okay, task 1 is going to be create cube. Okay, task 2 is going to be apply wireframe modifier. Okay, and task 3 is going to be, I'm going to rotate the cube along z-axis. Great. So first what we need to do, we need to create the cube. So let me delete everything. And how we will create a cube? Shift A, mesh, and under that we will go to cube. Okay, so here you can see bpy.ops.mesh.primitive cube add. Okay, let me just type that here, bpy.ops.mesh.primitive underscore cube underscore add. Okay, let's just run this code. You can see we are getting a cube here. So let me delete this. So now what I'm going to do is I'm going to apply the wireframe modifier bpy.ops. This is going to be an object level operation. Object dot modifier underscore add. If you want to see the script, you can just go here and add a cube and go to wireframe modifier section and go to the wireframe modifier. Just right there, and you can see bpy.ops.object.modifier underscore add, and the type is equal to wireframe. Okay, type equal to wireframe. Okay, now let's delete this cube and just run this. Okay, there's something wrong with the modifier, FIER, spelling mistake. Okay, great. run. So you can see the modifier is also applied now. Great. And you can notice one more thing here. I will show you another thing here. So if I'm going to use this and paste it here again, I'm going to delete this, and if I run the script, you can see the wireframe is getting applied only to the last object that we have created. Why is that? Because I already told you that operators only work on the selected object. So we are not selecting anything here. How is that happening? So what is happening here? Here the bpy.ops.mesh.primitive_cube is adding a cube, and after completing the task, it is becoming the selected active object. Okay, so next what is happening, we are asking the Blender to create another cube. So it is getting created, and the context is switching from this to this automatically. So when we apply this wireframe modifier, it is getting applied to the second cube. If we want to apply it to both the cube, then we can do something like this. So create and apply for that, create and apply for that. Let's try this. Okay, great. So we are having two cubes. Okay, let me delete this. We don't want this anymore. Okay, now what we need to do, we need to rotate along z-axis bpy.ops. So we are not going to use any operation here. We can actually access the properties from here itself. You can see in this place we are having the data. By just changing this data, we can rotate the cube. Okay, so how we will select the object bpy.context. So obviously this is going to be the selected object after completion of the operation, selected underscore objects of 0. So 0th index, at the 0th index, the object that we have lastly created is going to stay. So I'm going to fetch the cube from that place, and I'm going to perform a rotation, and it is going to be called as Euler, EULER. Okay, then along z-axis, right? So z plus is equal to 10. Great. Now let's run this. You can see it is rotated. You can also add another thing here. Okay, I'm just saying .y. Okay, and let's redefine this along z and y axis. Okay, let me delete this and let's run this. You can see it is rotated. Great. Now we have successfully defined the operation, but how to qualify this as an operator? So what is the use of qualifying? So by qualifying the operator, we can get the operator from this place itself, bpy.ops, and from here itself we can call this entire operation. Okay, for that we need to follow some structure. So what is that structure? So for that, first we need to put this inside a function called execute. Okay, def execute, and we need to pass self and context. Okay, so if you don't know why we are defining this execute and what is the self and context, I recommend you to take my Udemy course, and I will share you the link in the description. Okay, so class, and also we need to place this function inside a class. We can give any name, my operator. Great, and this class should be of type bpy.types.operator. So we have already seen what are types. So this class is going to behave like an operator. So we need to tell that. Great, and we need to slightly move this function inside this class. And one more important thing is that after successful completion of this task, we need to return a state called finished. Okay, great. So we have a function that will execute this operation, return finished. Okay, and one more thing that we need to add here is the properties. Okay, bl underscore id name and bl underscore label. Okay, this is going to be the name, my operator, and this is going to be the important one. The value that you are defining here is going to be the path. It's going to be the path. So this is going to mesh level operation dot mesh dot, then we can give our own name, my cube operator. Okay, this is great. So now we have successfully qualified our operator. After this, we need to register our operator. Okay, so how we will do that? We need to use the utility class. Okay, bpy dot You can see it from here itself, bpy dot utils. Okay, utils, and inside that you will get a utility function called register. So you can see register class. So this is a class you need to register, regi register underscore class, and we need to pass the name of the class as a parameter. Great. So let me run this. So it is successful. So we can go and find it from here, bpy.ops dot, what is this? This is mesh level operation dot and my cube operator. So you can see it is here. So if I'm going to run this operator, you can see it is getting executed. The entire function is getting executed. There is one more thing you can notice here. The class name that we have here and the label name that we have here is not going to be used anywhere. Okay, it is just for the definition purpose. We are actually interested in this particular thing, mesh.myCubeOperator. This is the one that is going to call this function. Great. So now we know that how to create custom operators. We can create a user interface in the next module. So in the next part, we will see how to create user interfaces.